When we look up at the night sky, we naturally assume the stars are surrounded by worlds similar to ours, stable rocks with rolling oceans and blue skies. To verify that assumption, we built the Kepler Space Telescope and launched it with a specific mission: Find Earth 2.0. Finding a distant planet hundreds of light years away requires some extreme engineering. We aren't taking pictures of the dark. We are analyzing the faint, distant light of millions of stars. This animated diagram shows exactly how we do that, using the transit method. When a planet passes directly between its host star and our telescope, the star's luminosity drops by a tiny fraction. By measuring that dip, we calculate the planet's size and orbit. From that data, we apply the Earth Similarity Index. This gauge ranks every discovered world from 0 to an ideal Earth-like one. The criteria for scoring a perfect one are incredibly strict, requiring a specific radius, density, and surface temperature. Our entire foundational map of the cosmos was driven by this goal. We were scanning the void specifically hoping to find our own reflection. Out of the over 4,000 exoplanets we've confirmed so far, a few actually hit that mark. Planets like TOI 700d sit relatively close to Earth in terms of size and composition. This diagram highlights the Goldilocks zone, the narrow green band where a planet is just the right distance from its star. This distance ensures conditions are stable enough for liquid water to pool on the surface. But searching for that perfect sliver of real estate meant we also cataloged everything that didn't make the cut. In our hunt for a familiar home, we accidentally mapped the remaining 99% of the universe. Our stable solar system is a cozy exception. The reality is that the cosmos is filled with absolute, undeniable planetary horrors. Take Gliese 1214b. It's a massive planet, fully engulfed in water, with no landmass, wrapped in a thick, boiling steam atmosphere. This global ocean plunges hundreds of kilometers deep. At the bottom, the sheer mass of water creates a crushing pressure of 20,000 atmospheres. That immense pressure forces liquid water to crystallize into a heavy, solid state, known as Ice 7, which sinks straight to the bottom. This dense ice wraps the planet's core in a massive, dark shell. In the dark void, we find rogue planets like WISE 0855-0714. These worlds were violently ejected from their host solar systems during their formation. Deprived of a host star, these orphan worlds drift in absolute darkness, kept warm only by the slow radioactive decay of their own cores. Even when a planet is made of familiar building blocks like water or rock, stripping away standard solar physics mutates it into something completely alien. Moving dangerously close to a star creates a different kind of nightmare. K2-141b is tidally locked, meaning one half of the planet permanently faces its sun, while the other is trapped in eternal, freezing darkness. On the day side, temperatures climb past 3,000 degrees Celsius. At this heat, the rocky crust melts into a magma ocean and evaporates into the atmosphere. The temperature difference between the two halves generates supersonic winds. These gales carry the vaporized rock over to the freezing night side, where it precipitates as rain made of molten magma. Scaling up the heat even further brings us to Kelt 9b. This gas giant roasts at nearly 10,000 degrees Celsius, making it hotter than most stars. The heat is so intense that the planet's atmosphere is packed with vaporized iron and titanium. Its parent star is actively stripping this heavy metal atmosphere away and blowing it out into space. Extreme proximity to a star turns these celestial bodies from passive planets into actively self-destructing infernals. Some planets defy explanation altogether. TESS 2b is a terrifying anomaly that absorbs over 99% of all incoming light. It reflects less light than coal. Because its surface is incredibly hot, it emits a faint, eerie red glow, like a dying ember. Then there is the ultimate cosmic horror, PSR B1257+12. This is a planetary system formed from the shattered debris of a supernova. At its center sits a pulsar, a dead star that bombards the surrounding planets with lethal, rhythmic pulses of radiation 10,000 times a minute. These environments represent the extreme edge of physics, where radiation and heat actively annihilate any matter that dares to approach. We built our telescopes and indexes to find peaceful mirrors of our own world. Instead, we discovered a violent cosmic laboratory where physical laws are stretched to their breaking point. The vast majority of the trillions of planets out there are deadly, extreme, and completely indifferent to human life. On Earth, we experience normal weather instead of raining rocks or vaporized iron. Standing outside and catching a drop of rain on Earth is a staggering mathematical miracle in an otherwise hostile universe.